I'm going to talk about hackathons, shared tasks, and papers, and my experience within my own project on collaboration with data and interdisciplinarity with data. So I was just introduced, but I will have a really short recap on me and my field. So I'm a PhD candidate at CLTL. I work on computational linguistics, which is sometimes called natural language processing, or NLP. There are slight differences between the two, but for all intents and purposes, today I'm going to talk about NLP as computational linguistics. And indeed, my supervisors are Antske Fokkens from the VU and Suzan Verberne, who is from Leiden. And NLP is basically teaching computers how to deal with language. It's a field that's related to computer science and AI as well. And you might not have heard of NLP, but you certainly have used it, because it is the technologies coming from NLP are used in services like spell checking, web searches, autofill. It's everything that uses data and technology, usually with language. And language and working with language data is very complex. So language is not as easy as other types of data. It has different nuances in meaning. People can say things without meaning exactly what they say in terms of pragmatics. People can talk about the same concepts or the same words in many different ways. So it is a very complex field and a complex data environment to find yourself in. If you're interested in learning more about NLP and my work, you can find me on Twitter, where I often tweet about my work and my field. And I have to give a sort of warning. What I say here are my personal experiences. They're not meant as universal representations of my field or of the events that I speak of. And any errors or misinterpretations are, of course, my own. Yes, so what is it exactly that I do? I work on diversity in news recommendation. So what does that mean? You probably have heard of news recommendation in terms of when you're on your phone and you get recommended news articles based on what you have previously searched on the internet, or you have a newspaper subscription for an online newspaper, and it provides you different articles that you find interesting. This is a news recommender system. And as you might have heard recently, there is a lot of debate on whether these are not causing so-called filter bubbles, so are not causing users to only see articles that support the user's viewpoints or the user's previously read behavior. What is a very good explanation of this entire field and basically this problem is the Fabeltjesfuik in Zondag met Lubach, which is they recently had this fragment on how this works. And my research is about how this actually can stop democratic debate. It stops you, if you're not aware of different viewpoints or different ideas in the news, it becomes very difficult to contribute to a democratic society because you're not aware of what's happening. You cannot talk with others. And my project is very interdisciplinary. So I'm the computational linguist in this project, but my co-PhD works in social science. There's a postdoc, Marijn Saks, in the project who works on the ethical implications on diversity in news recommendation and how to basically pop the filter bubbles, how to get people out of these narrow hallways of interest. And my job within this project is to automatically detect and diversify news recommendations and to automatically detect different viewpoints and ideas in the news with NLP methods. So what I will talk about today is the atypical approaches in NLP concerning data and how these approaches do or do not work for my project, for science in general, if there's such a word, and for interdisciplinary collaboration. So NLP is a young and very dynamic and a little bit of a strange field. So I work in the humanities department, but my work is very related to computer science for many reasons. We work with code and math. Often our approaches are more of an engineering approach, more like, can we build a system that does this, rather than hypothesis-driven research or any of the other research methods that are in the humanities. It's quite a young field. It started in the 50s, but there has been an explosive growth in the past few years, in the 2010s. There's also a lot of interest from more general computer science and from private companies who really like using NLP methods in their products. And the field is very dynamic. There have been a lot of recent discussions, for instance, on ethics and the involvement of larger tech companies in research about whether we want slower science rather than flag planting. So the field is going so fast with often methods that come out this year will be old next year. And people are talking about whether that's a problem and whether we should reward slower science. And one of the bigger problems, and maybe one of the more interesting ones for this discussion, is that NLP is not very good at carefully assessing and curating data. And this leads to problems, especially on very large pre-trained models. So models that are trained on millions of data sets, millions of texts, because it can lead to all kinds of biases, all kinds of problems with what your data is actually trained on. So these are current discussions happening in this field. What I found when I started thinking about NLP and data is that it is united in its approach, but divided by task. And what do I mean by that? So NLP has many collaborative forms of working with data. We have shared tasks, we have hackathons, we have benchmarks, and these are ways in which we use data as a community, but they're all different tasks. For instance, a shared task is where different research groups perform one task with the same data. For instance, a task can be detecting claims or summarizing text. So there's a goal. You want to automatically summarize these texts. Different groups work on this one goal or one idea. And then together they test this on the same data set. There's one test set, which is like an independent test or exam for all of the models. And then in the end, each of these teams presents at a workshop and they talk about what worked well for instance, summarizing text and what didn't work well. And there's usually one winning group. Hackathons are similar, but not really the same. So hackathons are also broader. They can also be used outside of NLP. And there are different groups compete on solving a problem or a question, usually in society, with a jury who then picks a winner. And this is different, so there's no test set, but there's also this inherent competition, and there are benchmarks. And benchmarks are data sets that are often stored centrally, and these are these independent tests. So it's a test to test whether model Y performs better than model X on a certain task, and this task can be claim detection. And different researchers or groups can submit a solution anytime they see fit. So that's why it's different than in shared tasks. People don't have to do it at the same time in the same workshop. And they can see how their solution scored compared to other researchers in a leaderboard. So you have a literal leaderboard where who scores what on which benchmark is scored. So they have a lot of collaborations and groups working together and together working on solutions, but there's also inherent competition. There's a best score, there's a state-of-the-art model, there are winning teams. And recently in my field, there has been talk about whether this is the best approach and whether this actually works. So this is an example of a shared task. I thought it was useful to give this. The task here is metaphor detection, and you see a description of what the model is supposed to do, right? The model is supposed to detect these metaphors in text. It gives deadlines, so when people have to hand in the models. It gives data sets, what data is worked with. And then people can send in their model to predict an unseen test set, so the exam. And here you see a graph of how different groups scored on this unseen test set. So this is only one example. And my thoughts on how this works and what I've seen in the community recently is that the competition can be nice. So there is a strong incentive to make a better model. In this sense, better means that it's better performing on this benchmark, or that it's a more accurate model at detecting claims or whatever. It has led to large strides recently in the rise of the large language models. So these huge models that are trained in millions of texts that turn out to be really good at some of these very difficult tasks, which all happens in a short period of time. And what is really nice also in terms of science and competition and comparing is it's very easy to have a uniform comparison of models and approaches. So you can just objectively see this is the same test and this is how this model does and this is how the other model does. So that's nice, but the leaderboardism, as it's sometimes called in NLP now, can also lead to the reward of only one type of research, which is sometimes called state-of-the-art chasing. So only wanting a model that's 1% better than the other model, and not careful reflection on what or why we are measuring this, or other aspects of models, such as an environmental impact on training these huge models, or generalizability. So maybe your model is really good at detecting claims, but a slightly different task or a slightly different data set will stump the model. And what is a bigger problem is that the leaderboard becomes the mean to an end. So it becomes the goal to beat the leaderboard, rather than it being a way of measuring how good the model is at a certain task. So at detecting metaphors. And this is especially the case for very big leaderboards and benchmarks. And there has been recent discussions and talks about this in the field. What do I personally think, especially when it comes to my research? So my research is a bit difficult in the sense that it's interdisciplinary and that it's on a complex societal problem. And I found that taskification, so they're very specific tasks like claim detection, stance detection, argument mining, which each have their own data sets, their own benchmarks, and their own definitions and literature. And this leads to a very specific fragmentation of ideas, basically, because stance detection is not very different or is very related to claim detection. But these fields or these data sets sometimes don't really talk to each other because there are different benchmarks and different goals and different definitions. So there's a large fragmentation because of this task focusedness. Another problem is definition. So I noticed, especially now I'm working with social scientists and with specialists in journalism, that these tasks and how they are defined are often not as connected to theory or to ideas from psychology or communication science, or basically on experts, but are sometimes more aimed at what is easy to measure or capture by these models. So computational language models are good at capturing some things, but not very good at capturing nuance. And sometimes these task definitions will cater to that instead of what is actually needed. And it becomes quite difficult to evaluate across different tasks and different data sets and different benchmarks. This has also been noted in the literature. The people that I quoted before, Emily Bender and her colleagues, have really talked about that this is a shift that needs to happen. We need to start talking about how to look beyond tasks and beyond these benchmarks. And I see the same in my own research. So for diversity in news, especially when you talk about ideas and viewpoints in the news, you have tasks like stance detection and argument mining, who are all interesting to me, but it becomes difficult to evaluate them from a higher perspective because they are so fragmented. And my own experience with these different forms of working with data, I have participated in the past year in 2 hackathons. This was one of them. It was a hackathon by the Dutch public broadcasters, and they actually wanted more diversity in recommendation in their Netflix, to say so, their NPO Start, which is a video recommender. And there were 5 teams who were competing with a jury, which was the NPO, and they provided the data. And our team was very interdisciplinary because we worked from the recommender system project, and we won, yay, and we wrote a blog about it. But I actually wasn't undividedly happy with what we did here because we were still very fragmented, working with different disciplines. So we had a philosopher, we had a social scientist, we had a computational linguist, but everybody kept working on their own sort of narrow field. Like the philosopher was really busy with definitions and terminology and what we actually wanted, which was really useful, but there wasn't much interaction between different parts of the the recommender. Obviously, the jury still thought it was a nice prototype that we built, but I found it really showing that we really needed to integrate better and more. So I worked on a second hackathon the past few weeks, and this was a more atypical one. So the hackathon that I just talked about was in 24 hours. So we had 24 hours that we nonstop worked on this. They delivered food to our house. We were like not sleeping, just working, which is normally what a hackathon would be. And this one was more atypical, as in it was a 3-week long one. It was remote work on different challenges, and there were no judges. Rather, every team wrote a short proceedings paper. And I felt this one worked better for my interdisciplinary collaboration. I worked with my co-PhD, who is a social scientist, on implementing metrics based on democratic theory in a news comment recommender. And here it went better, I guess, because we had more time. We had more time to think, to get to know each other, and how like theory and code and ideas all fitted together. However, that meant that we didn't have as many results. We didn't spend our time just throwing models at solutions and comparing different data sets. We spent a lot of time thinking, and that meant our results section was not as large as that of other teams. But I did feel much better about this way of approaching a hackathon, I think. And then we also had another project that was not as much focused on data, but was a paper in a day. So with the project group of the recommender systems, we wanted to write a paper together. And we read this blog that I haven't quoted here, that I should have, on that you can write a paper in one day. So we decided to try that, to try to write a position paper in one day. And of course, we couldn't finish it in one day, but it was really interesting to, almost like a hackathon, in 24 hours, really get to talk about what we found important, what we wanted to talk about. We used a virtual platform called GatherTown, which allowed us to walk around between different tables and have like different topics at different tables. So that was very useful. And it was also one of our getting to know each other exercises. So that really helped. My conclusion in terms of like popping bubbles, both popping bubbles in terms of recommender systems and popping bubbles in terms of NLP and NLP tasks. So NLP has a very atypical approach to data usage in science with the shared tasks, the hackathons, and the benchmarks. Many of these are aimed at collaboration and openness, but there's also this competition element, and discussion has come up about how useful this is for science and for the field. My own interdisciplinary collaboration has used these approaches, sometimes with success and sometimes not, and with different levels of success and different implementations. And my takeaway is basically reflect on whether the best practices of your field work for your research. So my research is quite atypical for NLP in the fact that I'm not working on one task or one specific subfield. So I have to really reflect on how to use the best practices. And I would really encourage people to collaborate, especially across fields, because you learn a lot from different disciplines and from trying to implement different ideas. Yes, so thank you for listening. I hope my talk was fun and or useful, and I'm looking forward to your questions.